Dear students, welcome to this session. In the module 4, we are going to talk about the decision trees, regression and artificial neural network. We will begin with the decision trees. So first of all, before getting into the decision trees, first we will understand what is classification and prediction. So classification is a technique of grouping or categorizing, or you can say also bucketing of the data points. So you will group into certain data points into certain classes. So that is how you identify the different classes, and that classification activity is done basically to identify the certain group is a different from another group. For example, if we take a bank's example, suppose we want to, before giving the loan, if the bank wants to check based on certain features or the attributes of the customer, if potentially he will default or not default. So we have two classes: defaulters, potential defaulter, or he will not default. So if we run, already bank will have the data, historical data. Based on that, based on the attributes, we can classify. So this is a two-way classification. That's also called as a binary classification. We have only two. For example, bank's example, defaults or doesn't default, yes or no. Or another example could be based on the certain parameters, okay, like a BP and all the blood tests, some of the parameters of the blood test. We can identify potentially a person will have a diabetes or not. So these are the called as a binary classification. Either it can be binary classification or it can be multi-class problem. Multi-class means what? You will group into different classes. For example, let's say you are doing the news mining. So after news mining, you will go through the different kinds of news and you want to classify it as sports, politics, technology, entertainment. It based on your requirement, you can classify into different classes. So either you can do a binary classification or multi-class classification. And what is a regression? Regression is nothing but a prediction. So we will have a separate model for that. Just to give a brief understanding, prediction is in case of a classification, it is, we call it is kind of a it is a categorical variable. So we are the output is a category, right? Either we will say, if it is a news mining, sports, politics, technology, entertainment. So these are the different categories of the output. Or if it is a bank's, yes or no, defaults or doesn't default, yes or no. So these are called as a categorical variables. The output is categorical variable. And if we take the predictions are continuous variable. Suppose if you want to predict the temperature is a continuous variable based on the certain parameters, attributes or features, you can call it as anything you want to predict. So it will be a continuous value. Prediction is you want to predict based on whatever the given input, that would be a continuous value. Suppose you want to predict the share price, okay, based on certain attributes, you will predict, that would be continuous value, right? It can be any number, okay, it can range from 0 to infinity. So it is a continuous number. So that is a prediction, which we will see later. And what is a decision tree? Decision trees are one of the most widely used techniques for the classification. So decision trees, why we use it for the classification purpose. Decision tree is simply way to guide one's path to a decision. So decision tree is a tree where it will lead to a one path which will ultimately end in a decision. And what is a decision here? Decision is nothing but a class. So if we take the bank's example, either it will end with the yes or no answer. And if it is a news mining, the decision tree will lead to either sports, politics, technology. So you will give the data points based on the different questions. In decision trees, there will be a set of questions asked, and it will lead to a decision of what category of news is that. Okay. Decision trees are hierarchically branched structure that help to arrive at a decision based on asking certain questions in a particular sequence. So decision tree is, for example, like based on a set of questions and answers to those questions, it will branch out and it will lead to an ultimate decision or a classification. And what is a good decision tree? It should be short, and it should ask only few meaningful questions. That's a good decision tree. And decision tree models, once we create, okay, how to create the decision tree we'll see in the next. Let's say you have, once the decision tree model is ready, we will train that particular model using the training data. And what is the training data? Training data is whatever the features you have selected or the set of independent variables. For the features, the synonyms are, either we can call it as attributes, features, or independent variables. And the value we are, or also it can be called as a predictors, okay, or predictor variables. And the output variable, that is called as a dependent variable. So based on these features or the predictor variables, you are, based on the values of these attributes or features, you are going to predict the output variable. So in the training data we will have all these independent variables with the value, also predicted value, what is the actual classification that is done, everything will be there. That data is taken to train the model. And once the model is trained, we will test it on using a test data. So test data is, you will not expose during the training. So only training data is used to tweak, do whatever changes, and once that is done, you expose it to the, give it to the test data, and out of that test data you will see how well it has predicted or classified. In this case it's a classification, how well it has classified into different category. Based on that you will find the accuracy, means how many accurately it classified and how many incorrectly it classified. You get a accuracy here, and also you will get a accuracy. So training you will conduct as long as you get a very high accuracy for with the training data, and similarly it should give a high accuracy rate for the test data. When accuracy is high, that model can be used for further production purposes. If the particular model you have chosen, if it is not giving a required accuracy, you have to go with the different models. And accuracy of the models depends on various factors such as complexity of the model, size of the training data. So complexity is, either your model, if it is very complex, then there is a chance of overfitting. Okay, overfitting means it will run very well on the training data, but when it is given with the unknown data, it will fail to predict. That is called when we make the model very complex. And on the other hand, if we make a very simple, so the accuracy would be less because there are more errors. So we have to have a optimized complexity. We should have a complexity with a optimized level. And the training data size is very important. If the training data size is more, the knowledge extracted from that data would be higher, so accuracy would be higher. This is the example caselet, predicting heart attacks using decision tree. In this particular case study, this is conducted by the University of California, San Diego. This is regarding the heart patients. So here, whenever people came with a chest pain and they were diagnosed with that particular chest pain, that is a heart related things, after diagnosis they want to predict. Okay, so the objective of this study is, the objective was to predict which of these patients was at risk of dying from a second heart attack within the next 30 days. So when it's chest pain, maybe it is a first heart attack and they will be treated, and when they are discharged, so out of those discharged patient, how many of them will likely have the second heart attack within next 30 days. So this prediction would determine the treatment plan. So based on the answer to this question, they can have a different diagnosis for those people. And what are the different attributes or the variables that are collected? Some demography related information, medical history related information, and the lab data. Lab data is basically blood work and different kinds of parameters that helps assessing the patients. And this particular case is using the decision tree, and the algorithm uses the CART algorithm. And you can see this is the output of the decision tree. So if BP is less than equal to 90, so there is if answer is yes, this is a very high risk, means there is a high chance he will have the second heart attack. They have given a 70% of chance is there. If BP is not less than 90, okay, the next question is age less than 62? If answer is yes, the risk is very low, means they may not have a second heart attack, 98% of the people. If age is greater than 62, next question is has sinus problem? If answer is yes, then it is a high risk, and the 50% chance is that they might get a second heart attack. If there is no sinus problem, very low risk, so 89% there is no chance of having the second heart attack. Decision tree problem. Okay, so you can imagine a conversation between doctor and a patient. The doctor asks the questions to determine the cause of the ailment. So based on the questions, he will try to assess what's the problem he must be having. He will try to predict so what kind of a issue he might be having. Suppose if there is no answer, then he will recommend some test to generate more data and options. So this is how experts in the industry field solve any kind of a problem. So this is true with any kind of a problem. There is a set of questions that are asked, and at the end we come up with some decision or some kind of a prediction. Human experts learn from the past experiences or data points. Similarly, a machine can be trained to learn from the past data points and extract some knowledge or rules from it. So from the historical data, we can extract the knowledge and we can use that knowledge to make future predictions. Decision tree would have a predictive accuracy which depends on, okay, so the predictive accuracy depends on these three factors. First one is, as we already learned, training data. The size of the training data, the more the data, the knowledge extracted is more, so accuracy is high. More variables, so variables is nothing but, you can say, independent variables or features or predictor variables, attributes, any word you can call. So if we have more of those variables, then there is a better accuracy. Also there is another problem with having more variables. So if any two variables are collinear, so that will result in a lesser accuracy. So we have to identify if any of the two variables are collinear, means they are having the same pattern. If both of the variables are in the model, it will reduce the accuracy. We have to remove the collinear, so it is called as a multi-collinearity. We have to remove the collinear variables. For example, if in the attribute set you have date of birth as well as you have age, so even though they are in the different data format, one is a date and one is a number, but they are highly correlated. So this will create a problem with the accuracy. We should have either age or the date of birth. In addition, good decision tree should also be frugal, so that it takes least number of questions and thus least amount of effort to get to the right decision. Frugal means economical. We should be there should be very crisp and very important questions, and the model, the tree structure should be a smaller, economical. It should be optimal. Decision tree example. We will see with one example how we come up with a decision tree. Okay, here is an exercise to create decision tree that helps make a decision about approving the play of an outdoor game. So here what we have set of parameters, and we want to predict whether outdoor play is yes or no, whether we can play outside or not. And what are the different variables we have? One is the outlook, second is temperature, humidity and windy. Based on these four variables, you are going to predict whether outdoor yes or outdoor no, means outdoor play is possible or no. To answer this question, one should look at the past experience, see what decisions was made in the similar instance. If lookup table has a similar question, then we can get the answer. So one way to solve this is, like, we have historical data, so we can store that in a lookup table, or you can think it as a database table. And if we have the matching record, like there is a record which is exactly outlook is sunny, temperature is hot, humidity is normal, windy is true, and whatever the answer was there, let's say answer is yes, then from that directly we can predict this as answer as yes. But lookup table is a one way of doing, but it doesn't involve the learning from the data. So it is just a comparison. We are not learning from the that data. Decision tree will learn from the past data. So whenever I have a new situation, it will go back to the lookup table, and it will find for similar record. If similar record is there, then it will fetch it, otherwise it will not. And any of data is missing, then the query will not yield the answer. So those are the problems with the lookup table. And another biggest problem is, whenever the question is asked, it goes through the complete data set. So suppose if you have millions of record, it will go and search, so that time is taken every time. But in case of a decision tree will not memorize the data. Decision tree will learn, extract the knowledge from that data, and with that knowledge it will answer the new questions, even though if it has not seen that kind of a question, but it has a capability to give the answer or do the prediction. Decision tree example. There are three disadvantages of looking up the table. So we already looked into this. As mentioned earlier, how to decide if there is a not a row that corresponds to the exact situation today. So whatever the question is being asked, let us say we don't have such situation in the database. So lookup table cannot give the answer. Searching through the entire past database. Okay, so this will consume a lot of time, and every time you ask the question, it will go and look into the database. And what if the data values are not available? So suppose if there is any missing value, it will not able to predict. That are the problems with the lookup table. So decision tree. So decision tree, as I said, it will learn from the data, and it will have a model, and it can answer any kind of a question. So we have a question which is this question, we need to answer this question, so we will build a decision tree. For that we have this is the training data. Okay, so you can refer to all these diagrams, and pictures are taken from the prescribed book. So refer to the prescribed book and you will get all the information. So this is the training data. Training data, we have all the independent variables, and we have a dependent variable. For all these attributes, we have the values here, and we know what is the decision here. Suppose, for example, if it is sunny, hot, high, false. False means it's not windy, then the outdoor play is yes. No. And another example, if it is rainy, outlook is rainy, temperature is cool, humidity is normal, and it is not windy, then outdoor play is yes. So this is what we are going to predict. So let us start building the tree. So root node. So what is the root node? I will go back to the tree once again. This is called as a root node. So this is where your tree starts. This is a root node, and these are the leaf. Okay, these are leaf where you get the actual prediction or the classification, and these are intermediate nodes or intermediate questions. So first task is to determine the root node. So how we find the root node? We have four variables. So what is the question we can ask is what is the outlook, or what is the temperature, what is the humidity, or what is the humidity, or what is the wind speed. Those are the four questions we can ask. But among these four questions, we should the criteria should be used by which one of these questions gives the most insight about the situation. So it is like selecting a question which gives most insight. So there could be a particular variable which gives most of the insight, and there are particular variables that gives least or no insight into the database. Least insight into the given data. For example, for any medical related things, okay, if there are set of attributes including the BP and the blood sugar, so every most important question that is asked about any patient is the BP. The first thing is a BP, and second thing is whether diabetic, things like that. So some are very obvious and some are not obvious. In this case, these variables doesn't make any obvious reason to select. And if you have a good knowledge about the domain where you are trying to implement the decision tree, you can select as per your knowledge. You will definitely do. For example, I just gave a medical field. If any project is being done which deploys decision tree, definitely BP and the blood sugar would be the first question that can be asked. Next, the creation of frugality is good one. Frugality, again, the structure should be very economical or optimal. That is, which question will provide us the shortest ultimate tree. Another way to look at this is, what if one is allowed to ask only one question? Which one? So you can just think you are allowed to ask only one question. So you will go for the most important question, right? So that is the another way of looking at it. The most important question should be the one that by itself makes the most correct decisions with the fewest errors. So you have to choose such a question which will help to which will help in answering most of the questions, most of the situations correct decisions with the very less error. Decision tree construction. So how do we start? Start with any variable. So this is a one way. Here the technique that is used is a least error method. So there are other techniques as well. So here the least error method is used. Start with any variable. In this case, outlook. We are going to start with the outlook, and it can have three different values. If you have seen the table, please keep the table book or the data along with you, so it would be easy to understand. So the outlook has three different values: sunny, overcast, and rainy. Let us start with the outlook, and we will select the rule. The rule as sunny no means what? If outlook is sunny, then outdoor play is no. This is the rule we are going to select. So I will go back to the table just to show you how many records are there for sunny. So sunny, if you see 1, 2, 3, 4 and 5 records are there. And if I apply the sunny and no, so I have sunny and no 1. That rule will hold good, means that rule is correct. Again, second, sunny and no. Next is sunny no. So I got the 3 where the rule will work perfectly fine. Next is sunny yes. So the rule has failed here. Next, again we have one more here. So I showed this, one more is here, sunny yes. So sunny yes. So the rule will fail in 2 cases. So how many errors if I choose sunny no? How many errors out of the 5 records? I will have 2 errors. I will go back to this page. So you can say attribute outlook rules sunny no. So how many error I have? 2 by 5. Out of 5 instances, this rule failed in 2. It succeeded in 3. Next, So what is the next? Next rule is overcast S. Okay, if we look back in the table again, if I choose a rule overcast S, so how many overcast are there? 1, 2, 3 and 4. Overcast yes, this is the rule holds good. Overcast yes, overcast yes, overcast yes. Here in this case, if it is a overcast, definitely the answer is yes. So we the number of error here is 0. The rule worked in all the cases. So overcast yes, how many overcast values are there? 4. So how many error? 0. Every time I applied the rule overcast yes, it worked perfectly fine. Next, similarly the third value is rainy. I will choose rainy and yes. If you go back and see in the table, there are 5 instances where outlook is rainy, and out of those 5 instances, rainy yes, this rule is true in 3 instances. It is in 2 it is false. So what is the error? 2 out of 5. So how many records I have? Total 5 plus 5 plus 4, total 14 records are there. And if I choose outlook, how many total, how much total error I will get? 4 errors out of 14 records. So we have 4 errors. Now whatever we did it for the first attribute outlook, we will do the similar thing for the next variable, that is, let's say temperature. And in temperature, if you use the rule hot no, you will find it will fail in 2 out of 4 situations, and similarly mild yes, it will fail in 2 out of 6 situations, and cool yes, it will fail in 1 out of 4 situations. So you can see, if I choose temperature 5 by 14, the error is higher. Similarly for humidity, the total is 4 out of 14. For windy, the total error is 5 out of 14. And then you have to check which is the minimum error. Okay, you have to select that question first, that attribute first as a root node. So if you see here, we have a tie here. The outlook as well as the humidity both have the same error, that is 4 out of 14. Then what we should do is, the next level what we should try is we should look for the purity. What is purity? Is a certain question has clearly classified, okay, with like a yes or no. So in this case, if it is a overcast, definitely we know the answer is yes, outdoor play is yes. But in case here we have a mixed classes here, so this we call it as a pure, okay, pure leaf. Okay, so if we find any pure leaf, we will select that particular outlook, and this would be the way we are doing it. But you can choose to have this, and the model will be different. The model by selecting this would be different, and by selecting this question, the decision tree would be different. And you can put both the models through the training data. They might be having different accuracies. So this is how we choose the first question. Now if you build the decision tree, the first question is outlook, whether it is sunny, overcast and rainy. So we already saw, if it is overcast, the answer is definitely yes, the outdoor play is yes. Now when we started with the root node, we give all the data, okay, so including the outlook to this particular node, and we do the least error and then come up with this kind of a structure. If it is a sunny, I will now use the data where outlook is sunny. So you are seeing this data. So how many records are there? 1 2 3 4 5 and 6. Okay, and these are from the data set where the outlook is sunny. Okay, let me go back and we'll just check it out. So you can see this outlook is sunny, and we are going to take this data. Here it is sunny again, and we are going to we are going to take this data, and one more is here, we are going to take this data. So total how many we have? 1 2 3 4 and 5. So for outlook as sunny, we have 5 records. Okay, I will go back. I didn't count it properly. It is not 6, it is 5. I will show you again. So what you are seeing here, these are the names of the attributes. I just counted them. So we will, so all this data is where outlook is sunny. So we have 1 2 3 4 5, and we have taken this data where outlook is rainy. So we have dropped one variable, so we will just drop that rainy, and we will take the rest of the data. Now on this data we will use the similar technique to find the least error among these 3 variables. First, initially we started with the 4 variables. Now we will have these 3 variables, and among these 3 variables we will use only this much data. Whichever has the least error, that would be my next question. Similarly, we do the same activity on the rainy side. Whichever out of these 3 variables, temperature, humidity, windy, whichever has the least error, we are going to select that particular variable as the next node. Okay, so if you follow the similar, if you do the analysis in the similar fashion, you will get a table like this. If I choose temperature, so these are the different rules. Temperature has 3 different values: hot, mild, cool. So hot, if I say temperature hot, no errors, so it will pass all the cases. If I say mild, 1 out of the 2 cases will fail. If I say cool, yes, no error. And total error is what? 1 out of 5. So the total error is 1 error in out of 5 instances. If you see humidity, 0 out of 5, and windy, 2 out of 5. So if you see this, the minimum error we are getting it for the humidity. It classified the data completely, and you get 2 pure leaves here. So you will have one node, you will ask the question humidity, and if it is high, you will classify it as no, and if it is normal, you will classify it as yes. And for the rainy side, you will do the similar exercise, and here you will find windy. It completely classifies the data, so false if it is windy. If it is not windy, then outdoor plays yes. If it is windy, outdoor plays no. So we get a pure leaves here, so it will completely classifies. The final decision tree will look like this. So outlook, on this side we got the humidity, got the 0. So if it is humidity high, the answer is the game is not possible, and if humidity is normal, the answer is the outdoor play is yes. On the windy side, if it is true, means what? It is windy, then answer is no. If it is not windy, the answer is yes. Now we can answer the question. Okay, you are not seeing it here. Okay, I selected the didn't properly select the recording video. So here I will just read out. The outlook is sunny, temperature is hot, humidity is normal, and windy true, means it's a windy day. Now we will go with this. Outlook is sunny. I will come on this side, so sunny. Next is the humidity. Humidity is normal, so normal means what? Answer is yes. So the decision tree will predict for our earlier question answer as yes, outdoor play as yes. So this is a just comparison with the lookup table. Okay, decision tree and table lookup. Accuracy 100% accurate. The reason is if it finds the record, it will give the answer, otherwise no. Here accuracy will depend. Okay, it depends on what model you have chosen, and how much training data is there. So it is accuracy will vary. Generality, So generality means how the model is, whether it is general or it is very specific. Table lookup is very specific, applies only when similar case had occurred earlier. But in case of a decision tree, it is very generic. Okay, it applies to all situations. Frugality, only 3 variables are needed. So if you saw the structure, even though we had 4 attributes, for deciding we needed only 3 variables. So we didn't go for all the data, only 3 variables needed. Now in this case, table lookup, we need all the 4 variables required. Simplicity, only 1 or maximum 2 variables values are needed. So in this case, if even there are some values are missing, still it can make a prediction. But here, if any of the value is missing, it cannot do the prediction, and is logical and easy to understand. So this is very easy to understand, right? So what kind of, so it gives us a even without telling, it tells Outlook is the most important thing, okay, when it is deciding outdoor play or not. And depending upon sunny or rainy, if it is sunny, humidity is most important. If it is rainy, wind factor is important. So we can decipher some of the information out of the data. But in case of a lookup table, it is just a table. What you see is just the data. You cannot figure out any sense out of that data. See, can be cumbersome to look up, no understanding of the logic behind the decision. Decision tree algorithm. So this is the algorithm how we make. Create a root node and assign all the training data to it. So first we create the root node and select the best splitting attribute according to certain criteria. So the criteria earlier we used was a least error. Okay, there are other criteria as well. So what we used is a least criteria, and then add a branch node to the root node for each value of the split. For each whatever the split we get, we add the branch node. And when we have the branch node, split the data into mutually exclusive subset. So when we have the split, so when we have the next branch, that all data is divided into those 3. All the data are mutually exclusive. Means if you remember the decision tree, on the left hand we had only data which has Outlook as sunny, and on this side we had the data which had the Outlook as rainy. So that is the split. We have to split the data. Repeat step 2 and 3. What is the step 2 and 3 is the same. Select the best splitting attribute, add a branch. Okay, so as long as you keep on doing this, so what is the stopping condition? There is some stopping conditions we will talk about. So these 2 are repeated as long as there are certain criteria based on the accuracy, based on the size, based on the complexity. We can stop doing this iteration 2 and 3, creating more branches. So we don't want to have a very large tree. At the same time, we don't have to have a very small tree. The large tree is a sign of a overfitting, and small tree is a sign of a underfitting. So we don't want to have both of them. So there are some stopping criteria. We'll look, then we will stop. So this is the how we build the decision tree. So splitting criteria. What is the decision based on how we split? The variable can be chosen based on different criteria, such as least error. What we did is a least error. There is something called as a information gain and genius entropy. So that is not for your syllabus. We use least error. So there are other technique is information gain and genius entropy. So we can why we this is important is so that we can get the most benefit. Means our data is clearly, it is a very crucial step to select a variable which has a most insight into the data. For binary variables, 2 values will be used to split. So binary, we know yes or no kind of a category. 2 values will be used. For continuous variables such as age, BP, etc., a range can be used to make the bins. So here in case of a decision tree you cannot have a continuous value, but if there is a continuous variable, what you can do is you can put a range, like you can say age group 0 to 10, 10 to 20, those are called as a bins, or BP, ranging from 80 to 90, 90 to 100, like that. So you can make them as a range, and those ranges can be used as a classes. The number of branches at each node depends on the variable type, that is binary or continuous. So if it is a binary, definitely there are only two branches. If it is a continuous variable, for example age, like you have 5 ranges, then it will split into 5. And what is the stopping criteria? Stopping criteria, when certain depth of the branches has been reached. So we will aim for a certain depth. Like let's say like a branch can go up to say 8 layers or 7 layers, and you want to stop. And the other technique is error at any node is below the tolerable levels. So you calculate the error at each node, and you want to have an error less than the tolerable levels. These are the different algorithms. We have C 4.5, CART and CHAID. These are the different algorithms are there for making decision tree. This is the full name. Some basic information is used here. What kind of algorithm is used inside, when it is developed, and what are the types. C 4.5 is a classification, and CART can be used for both classification as regression. So these two can be used for the classification and regression. Then type of data, discrete or continuous, discrete and continuous. Non-normal data also is accepted. Types of splits, multi-way splits. So here you can see CART binary splits only. Clever surrogate splits to reduce the tree depth. Here multi-way splits as default. So you can set here either multi-way or two-way. Splitting criteria. So we talked about splitting criteria. So here C 4.5 uses information gain. Here it uses the Gini's entropy. Here it uses the chi-square test. Pruning criteria. Clever bottom-up technique avoids overfitting. Remove weakest links first. So pruning means we will not allow the tree to grow. So we use some pruning. So pruning is like cutting the tree. So these are the different techniques that are used. Here it removes the weakest link. Trees can become very large. So here the pruning is not implemented. Implementation publicly available. So publicly available, most packages popular in market, research for segmentation. So these two seems to be the open source packages. Now we have a decision tree algorithm hands-on exercise. So here this is an exercise you have to perform whatever. This is the training data. In the training data we have information about a customer, like his age, job, whether he owns a house, and his credit score. And based on this, loan approved, we want to say yes or no, whether he will be approved with the loan or not. This is the training data. Already you have this kind of attributes with the values, and for those values you know the decision yes or no. And what you have to solve is, then solve the following problem using your model. So whatever the model we build for, let's say age is young, job is false, house is false, means no house, no job, and credit is good. We will build a decision tree, and we will apply this particular question, and we will see whether loan gets approved or no. So to help you, what you have to do is start with the age, make rules. For example, what is the first attribute is age, and rule, you will say young, no. So you can just look up all the young, no, young, yes, young, yes, young, no. So if you see, if I have a rule young, no, in out of these 5 instances, I would be right in 3 instances. So the uh, the error here is 2 out of 5. So if I choose a rule young no. Similarly, you will choose middle, either no or yes, whichever gives the least error. Similarly, old, you can see old yes, because I see all the yes except one. So if I say old yes, 1 2 3 4 are correct and 1 is incorrect, so error is 1 by 5. Okay, that way you can decide which question to be asked first. So you will do it for the age, you will do it for the job, you will do it for the house, you will do it for the credit. Out of those 4, whichever has the total error which is least, you will select that variable, and from there you will build the next branch and you will split the data. For example, let's say your just I will take job. Let's say based on the job, this comes out to be having the least error. Then you will say job. After that job, it will have either false or true. Only 2 parts can be there, true and false. And when you are choosing the next, so for true you have to take the values for the true branch. For the false branch, you have to take the data where job is false. So that is how you have to split the data and follow the same procedure repeatedly until you come to the one level where you feel that this model is good enough.